This is lessons 8.2 and 8.3. We're going to be proving triangle similarity by 3 shortcuts. The first shortcut is AA, or angle similarity. And that's if two corresponding angles are congruent, then the triangles are similar. So here we had one that was already marked, and we also had our vertical angles that were congruent. So we have two pairs of angles that match, so this would be AA similarity. A different way could be side-side similarity, SSS. So instead of looking for all 3 pairs of sides to be congruent like we do with congruency, we're looking for all 3 pairs of sides to be proportional. So just like from 8.1, when we put the pairs of sides, the matching sides, into fractions, like we would put PQ over TS, that would be 3 over 6. I would put QR over TU, that would be 5 over 10. I would put PR over SU, that would be 4 over 8. All 3 of these fractions reduce to be the same thing. They all equal 1/2. So that is how we know that sides are proportional, if their fractions are equal. So if all 3 pairs of sides make the same fraction, then it's similar by SSS. And our third method is SAS, or side angle side. So that's when we have 2 pairs of sides that are proportional. So the 8 here and the 6 here, right? 8 over 6. The 20 here and the 15 here, 20 over 15. So this is 4 over 3. This is 4 over 3. Those 2 sides are proportional. And then the included angles, the angles in between those 2 sides, or the angle that happens at the point where the 2 sides meet, are congruent. So this is a mix of angles being congruent and sides being proportional for the triangles to be similar by SAS. So for example 1A, we want to determine if the triangles are similar, explain why or why not. If they are similar, we're going to finish the similarity statement. So we have triangle AEB, which has angle A and a 52-degree angle. And then we have triangle ADC, which has angle A and a 52-degree angle. So both triangles have the same angle A at the top. This angle is a reflexive angle. Like we had a reflexive side in congruency for triangles, we have reflexive angles when they overlap like this. So there are 2 different angles that are congruent here, right? We had the 52s and the A's. So these would be similar by AA. And now AEB would match with ADC. So triangle ADC. Example 1B is the same thing. I have overlapping triangles again. I have a little guy right here for WQR, but then I have a larger one right here. So what I do when my triangles are overlapping, I tend to draw them separately. I redraw the bigger version and just highlight the smaller version within it. Both of my triangles had the angle by W. They overlapped there. So we do have an angle that's congruent. The whole length of WS, from S all the way to W, this whole side is 30 plus 15 together. That's 45. And this whole side for WZ, from W to Z, is the 14 and the 28 together. That's 42. When I want to check if my sides are proportional, I'm going to pick in my little triangle, the bigger of the 2 numbers was 15. And in my bigger triangle, the bigger of the 2 numbers was 45. In my little triangle, the smaller of the 2 numbers was 14. And in my bigger triangle, the smaller of the 2 numbers was 42. By doing this, I know which sides should be in the same fractions. So 15 should be in the same fraction as 45. 14 should be in the same fraction as 42. And I'm going to reduce both. 15 over 45 is 1 divided by 3. 14 over 42 is 1 over 3. So it works that we have 2 pairs of sides that are proportional And in between them, we have an angle that's congruent. So this is SAS, and WQR would match with WSZ. Still the same thing in example 1C. In this one, I have some parallel lines. So these little triangles here, remember they mean that the lines are parallel. And when we have a shape that looks like a bow tie, we have alternate interior angles. So angle S and angle U would be congruent to each other, as well as angle R and angle T. Also, we could even throw in our vertical angles are also congruent. So we have 1, 2, 3 pairs of angles. That's AAA. We only have a method that's called AA, so that's what we will call it. And then SVR, so S matched with U, then V with V, and then R with T. Still more, example 1D. I have 3 pairs of sides here. So I'm going to look at the biggest side in this triangle was 35. The biggest side in this triangle was 28. The smallest side in this triangle was 30, and the smallest in this one was 24. That means the middle side was 32, and the middle side was 25. Again, I do this so I know which numbers should go in fractions together. So 30 should be in the same fraction as 24. 35 should be in the same fraction as 28. And 32 should be in the same fraction as 25. So for these, I'm probably going to just divide them to see what decimal I get, or I can reduce the fractions. 30 over 24 reduces to 1.25. 35 divided by 28 reduces to 1.25. And 32 over 25 reduces to 1.28. All 3 are not the same. So this is actually no, because the sides are not proportional. All right, so this one could have been SSS if all 3 reduced to be the same thing, but it wasn't, so this was just no. Example 1E, we have another pair of overlapping triangles. So for this one, we have triangle DAE, which has angle A in it, and we had the larger version, also with angle A in it, of BAC. They did tell us the whole length of AB here was 25, and they did tell us the whole length of AC here was 21. So we're still going to take the bigger of the two numbers, the bigger of the two numbers, the smaller with the smaller. So 25 is going to be in the same fraction as 15. 21 is going to be in the same fraction as 12. Again, I could either divide or reduce. If I reduce, this divides by 5, 5 over 3. This divides by 3, so 7 over 4. They're not the same. So this is no again for the same reason. The sides are not proportional. There's really only 2 reasons that we're going to have besides not enough information is given, and that's that the sides are not proportional or that the angles are not congruent. Those are the only 2 things that could really go wrong with our similarity. One more together. So here we know we have a 90-degree angle in both, so there's at least one angle that matches, but 26 doesn't match 64. That doesn't mean 26 doesn't match angle K. So what I would do is I would say, okay, well, in this triangle here, HGK, I know I have 90 plus 64 is 154, and a triangle adds to 180. So 180 minus 154 is 26. So this missing angle on this triangle was 26 degrees. And now look at that. Those do match. So we had the right angles that matched and the 26 degrees that matched. So this is A. And triangle C, D, E. So C matched with K, D matched with G, and then we have H. So there will be a set of check-ins for you to try. Pause between each one, and answers are posted on Google Classroom. So here's check-in 1A. Here's check-in 1B. Here's check-in 1C. And here's check-in 1D. So for example 2, it says, is either triangle DEF or triangle GHJ similar to triangle ABC? So we want to know, is it triangle 1 or 2 that is similar to triangle ABC? What I will do, they've already colored them for us on here, but if you're looking at it on paper, it wouldn't be colored. So what I would do is the biggest side of each, I would identify with one kind of mark. The smallest side of each, I would identify with a different kind of mark. And then the middle side, middle side, middle side. I can only compare 2 triangles at a time. So let's say I compare triangle ABC to the first triangle. That means I'm going to have 8 over 6. I'm going to have 12 over 9. And I'm going to have 16 over 12. It's very helpful to use the symbols that we've marked our pictures with to tell what goes together in a fraction. So 8 over 6 is 4 over 3. 12 over 9 is 4 over 3. And 16 over 12 is 4 over 3. So they're all equal. So these are the 2 that are similar. DEF is the one that's similar to ABC. So triangle ABC is similar to triangle DEF. We don't have to check the second triangle because it said is either one similar, not are both or which are, just which one was, and we've already determined it was DEF. So here's check-in number 2. Just determine if the triangles are similar. If so, explain how and write a similarity statement. Answers are posted on Google Classroom. For example 3, a flagpole casts a shadow that is 18 feet long. At the same time, a woman standing nearby who is 5 feet 4 inches tall casts a shadow that is 40 inches long. How tall is the flagpole to the nearest tenth of a foot? So you can see we have a little diagram here of a person, and on the ground is their shadow, a flagpole, and on the ground is their shadow. We end up with 2 triangles if we connect the top of the figure to the ground. And we know that they're similar by AA because the sun is creating the same angle with the ground, with both of them, because it's the same height in the sky for both of them. So we can use the fact that the triangles are similar to match up the height with the height, the base with the base. We know on the flagpole, the shadow is 18 feet, and the height is X feet. For the woman, we know her shadow is 40 inches, and her height is 5 feet 4 inches. So I'm going to turn this into just inches so that it matches the other units in that triangle. So 5 feet 4 inches, 5 feet times 12 inches in a foot, 5 times 12 is 60, plus the other 4 would be 64 inches. So we're going to take height with height, base with base, and we're going to make a proportion. 64 over x is equal to 40 over 18. I'm going to cross multiply this, so 40 times x is 40x, and 64 times 18 is 1,152. And when I divide that by 40, we get 28.8 feet. It's okay that we had different units within the 2 triangles. One of them was in inches, the other one was in feet. That just means in our proportions, we had inches over feet and inches over feet, which is okay because it matches. The tops are the same, the bottoms are the same. If I had switched and put 64 over 40 and x over 18, that would also be okay because it would be inches, inches, feet, feet. As long as we're consistent throughout our proportion, it won't matter. So you're going to try check in 3, same woman as before, but now there's a child, and we want to know the length of the child's shadow. Answers are posted on Google Classroom. For the final problems, we're going to use the similarity statement much like we did in section 8.1 to know what parts go together and set up proportions to solve. So AB matches with DE, DE, BC matches with EF, and then our last sides would match as well. I want to make a proportion, but only use one of the x's. I don't want to have both x's in my proportion. So I'm going to choose the x minus 1 because it's less complicated than 3 times x plus 1. So I'm going to pick the x minus 1 over its matching side of 18. I'm not going to use this side, which means I'm not going to use this side. The pair of sides remaining to me is the 4 and the 12. We have to be careful. If I picked from triangle ABC first to put x minus 1 on top, then I have to pick the 4 first over 12 for the second fraction. Pop some parentheses around that, and let's cross multiply. 12 times x minus 1 will equal 4 times 18. So that's going to be 12x minus 12 equals 72. Add 12, we get 12x equals 84. And when we divide 84 by 12, we get x is 7. So there's one final problem for you to try. Answer is posted on Google Classroom. But that is it for sections 8.2 and 8.3.